Alright, welcome back guys, and we are solving these questions right here. Alright, so let us start. So should I go from here to here, or so let's just start from C, right? 1 2 3, yeah, let's just start from C. The question is submit code. I can submit it here. Okay, so let's say first you are given an array of length a to n. Okay, each integer from 1 to n occurs exactly twice in a, right? So let's say these integers 1 1 2 2 3 3 4 4, right? 8 size array, let's say, right? Initially your score is 0. You can repeatedly perform following operations while a is non-empty. Okay, so choose an integer x that is present in a. Okay, and let L and R be indices of the leftmost and rightmost occurrences of x. Indices of leftmost and rightmost occurrences of x in the current array recursively. If x occurs only once, then L is equal to R. Add R minus L plus 1 square to a score. Delete the elements AL plus 1 to AR. From A, the remaining elements are concatenated without changing their order and indexed from 1, starting from 1. Okay, so let's read again this question, right? So we have an array of length 2n. Okay, an integer is 1 from each integer from 1 to n occurs exactly twice in a. Score initially 0. Okay, you can repeatedly perform the following operation while a is non-empty, right? Repeatedly perform the following operation while a is non-empty, right? What operation? We will choose an integer x that is present in a. Okay, let L and R be the indices of the leftmost and rightmost occurrence of x in the current array, because it only is there 2 times, so L and R will be 1 only. 2 means especially if x occurs, L is equal to R. Okay, add R minus L plus 1 square to your score. Add this R minus L plus 1 square. Delete the elements from L to AR from A. Okay, so let's say we have this array, right? 1 2 1 3 4 4 and 2. So let me choose this 2 as, so L is this, R is this, right? So what will be the score for this? This is 1 2 3 4 5 6 7. 7 minus 2 plus 1 means 6 square, which is 36. Then we delete all of them. L and R remain L and R here. So this is 1 square is 1. The score will be 37 total, right? In this case it is 37. But let's say we had this we chose let's say 3 is also there, right? 3 here. right? So 3 is here, 1 2 3 4 5. 25 score, it gave us 25. Then I chose this 4, no, 2, it is 4, then it is 1 only, right? So 25 plus 4 plus 1, which is 30. It is not greater than 36, right? Let's say we had like this, right? So it will be n square, right? N square, like, because this is 2 square plus 2 square plus 2 square plus 2 square, right? So 4 into 2 square, which is 2 square, it is 2n, right? 2n into 2 square, no, n into 2 square. So 4n, right, will be the maximum. So 32 is the, like, this maximum, right? Because we are just deleting this portion, but what will be the maximum in this case? What is here? L, R is here. So now what is? Now we have this R is 8, right? 8 minus 1 plus 1, which is 2n square, right? 2n square is when we have this maximum, right? So this is where we can maximize our score, right? So we should choose our score such that the element must be like L and R have the maximum, R comma L must have max gap. If those have max gap, then we can maximize the score also, right? Otherwise we can't. So we have to find maximum RL for such an element, right? Then we choose that element first, right? Because we have 1 2 3 4 1, right? Then we have 5 2 3 4 5, let's say. So we choose 1 1, which is 1 2 3 4 25 plus 1 2 3 4 25, which is 50. But if it was like this 5 and 5 and this was 1, if I choose 5 5, so it was like 10 square, right? It is 100. So it will be always maximum, right? Yeah. So we either choose the rightmost widespread. So for which element we have the so we can do one thing. We can choose one element, like it is L is here and right is here, right? We reduce right. Okay, this. We found here it is, right? Like, okay, 1, like this, like 1. Okay, this is 1. Right. Now this L and R max is what? It is 5, right? Let's say it was like this. So 1 5 2 3 1, right? 2 3 4 5, like this. right? So if I asking for this 1, so I am getting this 5, right? But if I move forward and ask for 5 here, then I get this 9, right? So for each element I have to find, right? So it will be order of n square, in worst case, right? It will be order of n square. And also we have to delete those things and all, right? So is there any optimization for that? Is there any optimization? It will be Is there any optimization for this case? Can you find that? Is there any way, guys, to do this? Let me open the code for that also. Right. Okay. We have to write in this, but what could be the possible solution here, guys? How can we do this, guys? So we have to choose the optimal index, right? L and R. And order of n square is very simple, right? So we try to write code for this order of n square. So do we try this? Let's try this first, right? Let's try to solve this with brute force first, then we will optimize. Okay. 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 We will have some. Suppose input is part is the input format. Let's check. Each test contains multiple test cases. The first line contains a number of test cases. Okay. The description of the test case follows. So into manage will be like entity will be there, right? Test case and see. Okay. Right. Then description of the test case follows. The first line of each test case contains a single integer, and second line contains two n integers. Okay. It's guaranteed that the each integer from 1 to n occurs exactly twice in an A. It is guaranteed that the sum of n overall. Okay, let's go for test case, right? So solve t, right? So we will have this into solve integer t, right? Then what we can have is so we can do this for int I for int I equal to 0, I less than t I plus solve t. Let's solve, right? Just solve. We don't need to do this. Okay, here we have integer n first, then we have a vector of type, or we can say array of 2n size, right? 0 here. Then we will have for int I equal to 0, I less than 2n, I plus 2 into n, I plus plus, and c n will be like array I, right? Then this will be our input. It is guaranteed that integer when related to question A. Okay, it is guaranteed that sum of n overall test cases does not exceed this. So integer is like in character range, right? That's okay. Now what we can do, guys, is we will have two loops, right? So for int l is equal to 0, int r is equal to 2, let's say, okay, int m is equal to 2 into n, right? So let's say m minus 1, right? Now what we can do, it is one indexed, right? So we will manage that, right? So for int here I equal to 0, right? Okay, while we are like so we will count how many we have already found out about, right? How many teachers we have already found out. So So we have to have a count integer, count is equal to 0, right, while count is less than n, right, count is equal to 1, okay, less than equal to n, right. Till then we can do this, and for an integer, for int I is equal to 0, I less than n, I plus plus, okay. So integer we can say number, right, number is equal to arri, we have this. Now what we can do is r, we have to choose the r, right, while here r, right, is not equal to here I, right, like this. Then what we can do, we do r minus minus, right, if it is equal to that, if we found out, then we have to find out the difference, right. Okay, so here it is, and if we have found out this, then what was the formula? Formula was r minus l plus 1 square, right, the difference is right, like this. Then in this case in that case, guys, is this is one indexed, right, so r will be r plus 1 in this case, l will be l plus 1, plus 1 will be like this, okay. So r plus 1 minus l minus 1 plus 1, it end up r minus l plus 1, right. Let's say it was 0, l is 0, r is 2, or in the other case it will be 1,3, so it's same, right. So doesn't make so much difference, 2 minus 0, number of elements we have to just count, right. So it is 1 index, 0 index, doesn't matter here. So difference which will be difference is equal to r minus I plus 1, right. If diff is greater than max diff, right, in that case L is equal to I and R is equal to R, we have to do the we have to have the max r equal to 0, or we can say m minus 1 also, right? And we will, if this is r, right, for r what we can do is int r is equal to error dot size minus 1, like this, right? And number is error of I. We have our max diff, and max diff is 0, right? And int diff is this. L will be there. L is equal to I, and R is equal to not R, max R is equal to R, right? So when we have this okay, so we are finding for every element, right? For I plus plus, like this, less than n. Less than 2 into n. Okay, we can do this. And while no is equal to error I, and L is less than R, or we can say I is less than R, or less than is equal to, we can do. Then only we can do one minus, else we will not do. Diff is like this. Okay, we have found the maximum L and R, right, for this case. Now what we will do is we will found the answer, the score. Score is equal to POW over R max R minus L plus 1, comma 2, right? And we have int score equal to 0, and while ARR dot size is greater than 0, right? Or we can say empty also, right? Is empty now. Size is greater than 0, right? After this, what we can do is we can delete that, right, between those. So how to delete it? Let me find out how to delete elements in a vector in C++ between two indices L and R. Right? So to delete elements vector between R and C plus A, use the vector erase function with iterator arithmetic. Okay. Both elements are inclusive, so if you want to delete anything from index L up to index R, you must set iterator to L plus R plus 1 plus L, okay, okay, like this. Index L is inclusive, R is exclusive. We want to delete everything starting at index H, but stop right before index R. Pause this. Okay, both inclusive, both exclusive. Okay, so I can do is here is ARR dot erase ARR dot begin plus L comma ARR dot what was that? Only begin only begin plus max R plus 1, right? Just to be able to read this. And after that solution we can print the score, right? How to print it? See out score, right, like this, and we will return 0. Is this correct? Let's try. Let me try it. Okay guys, let me try my brute force solution first. Choosing our file, DSA, right, and man.cpp it is. Let's select. Okay, I have to submit it also. Okay. Okay, it's a TLE on test 1 only, right? It is not like a very optimal solution from my side, but I think if I do try to run this, right? If I try to run this, how to run C files? How to run C files, guys? How to run C++ file in terminal in VS Code, let's say. What? Is there any simple command or not? G++ standard C70 main CPP. I will do just main G++ main CPP O main. Okay. So G++ main.cpp O main whatever. Return. Wow, it is not in. Just about it. Alright. Okay. Let me do this. Okay, dot slash main. So it is asking for a script. I will have one test case only. Let's say one. We need call that instance student max size. What is there? So what is the n here, right? So n is not defined. First I have to take this n, right? C n first. That's how I will do. One only, and n will be let's say our it is 8. 8 elements will be, right? So how our 8 elements would look like? Let's give some example. We have taken, right, 1 2 3 4. It is 4, right? 4 3 2 1. 1 2 3 4 5 6 7 8. Okay, let me try this now. Whatever. Hmm. 2 into n. Whatever. Test case is 1 only, so it should be only run one time, right? This one time, this should go here. Okay, let me give it to you. Where the hell? Okay. Let me do it one more time, right? One test case, 8 elements are there. 1 2 3 4 4 3 2 1. What now? And 2 1 2 3 4. What is happening? Can you tell me what is the solution? Okay. Here in max this current size. Okay. Let me try this solution now. Very similar. I use base sync with the studio false optimized for competitive programming. Cin.i is called null. Okay. G++ man.cpp man / man. One test case, 8 elements. 1 2 3 4 4 3 2 1. Whatever. Answer is 226. Wow. T solve. Right. Solve is int is n. C in n. Okay. Vector. Give me input file for this code. Okay, 3 2, let me see, and it will be our input.txt here, right? And dot slash main input.txt. What happened? Oh, there is nothing input. (1618.4). Is this correct answer? (1624), but we have our answer 1618.4. Why is it so? Okay, let me give you this input here now. Okay, let me take this input from here, right, from this problem, and I will check the output for this, right? Okay, now this is 4, 10, 16, 20, right? Let me check. 4, 10, 16, 20, 36, 28. That is, so brute force is like correct. Our brute force, right, guys? Our brute force is correct here, and okay, we have to update this also. That's wajib. And total score plus is equal to, okay, we have to do that also, right? So our solution was like 90% correct, right? 10% there was a small box, but logic was correct, right? Now let me try to submit it here, right? Can I submit it? I choose a file with from this main.cpp here, and I try to submit it, right? Wrong answer on test 2. So test 1 is correct, but test 2 is wrong answer, right, guys? So can we optimize this? At every move you may choose any number of number that is still present, right? That is the case. But now if there are many choices, if brute force solution would try like choose x is equal to 1 like this, we are trying like this, right? So the one idea we already figured out is the bigger is below, the L and R, the bigger the gap, better we score, right? Better the bigger the gap is, right? This is like we found out, right? So we have to choose uh, the largest block and remove it, right? To score maximum. So, so the one thing also given is each number from 1 to n, right, appears exactly twice. So for every value x, there are only two positions in the whole array, first occurrence and second occurrence, right? That means when we eventually use x, so can we do the binary search like for I, then we find the from here to here the next element. So it will be like n into log n from n square, right? For order to n square to n log n. Yeah. So there are two cases. We delete x as a singleton, meaning its other copy was removed earlier, right? And we delete the whole block from its first occurrence to its second occurrence in the current array. There is no third case in this case. So can we solve this problem by looking at positions from left to right? Right. So guys, the thing is, uh, this problem, okay, let me show something to you about the problem, right? Oh, whatever. Right. So the problem here, guys, is, you see, let's take this, right? Let's take this example and put it here. Right here. Now you see, this is given that every element is only twice, right? Only becoming twice. So let's say we have found this. We have found this interval, right? Then this interval and rest of array are independent now, because I am telling you independent, because this will be deleted after that, right? So now the score of this array is not dependent on this, right? So we can treat it as interval, as an interval, right? Which is independent interval also, independent interval, right? So we remember that when we have some interval problems, right, that can be solved by the prefix and suffix dp, right? You know, but the condition there mostly occur that the array, the interval naturally should divide the array into independent parts, right? So what is a prefix? A prefix simply is, let's say we have this array 1, 2, 3, 4, 5, right? Let's say prefix of length 3. So it will be like this: 1, 2, 3, right? So suppose I already know the answer for this part of the prefix, right? Right? So can I use it to compute the answer for 1, 2, 3, 4, 5? Let's say if I know the answer for this, can I use this answer to know the answer for this array? If yes, then dp of I is possible. It's possible, guys. This is how we treat a prefix dp, right? So why does this dp love prefixes so much, right? So the thing is, dp will work whenever you have the optimal answers for a larger problem. Whenever you can build optimal answers for a larger problem, right, from the optimal answer from the smaller problem, like this, right? So for example, you have maximum subarray, right? Maximum subarray. So what you do? You do like ending at I depends only on ending at I minus 1, right? So there also prefix dp work, right, in maximum subarray. dp work, right? Now think about interval. Suppose we delete this interval. Let's say we have this 1 2 3 4 5 6, and we delete this interval, right? If these parts never interact, then answer will be like answer of left, right, plus answer of right, like this, because they are not interacting. It will give us the whole answer, because they are both parts are independent, right? So whenever a problem naturally splits into two independent pieces, then DP is possible in that case, right? Suppose we have this array 1 2 1 3 and 3, and we found out this interval. So when we select this interval, this is very independent from this interval, right? So we take this interval, everything before is very empty, right? Everything after it is only 3 3. So once we decide that take this interval 1 to 3 here, from here to here, right? So remaining problems is 3 3, like this only. So we will not care about how we got here and all, right? It's completely new smaller problem for us. This is exactly what DP needs. We delete this interval, and now we will solve this problem only, right? So why these prefixes are appearing so often, right? So let's say our last interval is L is left and I is here, right? Like this. Then everything before, let's say 1 to L minus 1 is independent, right? Independent, because we are going to delete this interval, right? So answer becomes answer of left plus current interval, right? So this is very similar to dp of L minus 1, answer of this, right, plus cost means like this, whatever we, or you can say it is score also, right, current score as of our problem. So notice here how naturally prefixes are appearing, right? Nobody forced it, right? Very natural. Interval itself created the prefix here, right? So let's take one more intuition. Sorry, let's say we have this 1 2 3 4 5 6 7 8, right? Then let's say this interval is there, right? Everything before 1 2 is untouched, right? So let's say dp of 2 already knows its answer, right? That's why we write dp of L minus 1 plus interval score, let's say like this. So guys, do you understanding how we are dividing this array problem in intervals and giving our dp, moving to dp, right, to get the correct answer? So you think, so whenever you see delete interval, you should start, when you delete interval, there is an interval included in the problem, right? So if you have interval, right, you can start thinking about intervals. You can start thinking about prefix and suffixes, right? And you can also start thinking about dp on intervals, right, on dp on prefixes, right? So you can start thinking about these also, because interval problem are often solved using GP, right? And this was the step one. What are the changing variables, right? What are the changing variables? After deleting the interval, what changes? Array changes, right? And also indices changes, right? So usually when we change arrays, it's scary. Changing arrays are scary. So you can have this answer. Okay, can I describe the operation without worrying about changing indices, right? So you see here each number appearing exactly twice in the problem, right? As you can see here, each number is appearing twice in the array. Okay, that's a huge clue for us. Normally a number could appear many times, right? Here 1 is exactly twice, 2 is exactly twice, 3 is exactly on 2 positions, right? So every value naturally defines one interval, right? This is defining this interval, this is defining this interval, this is defining this interval, this value is defining this interval. So every value is defining one interval for us, right? So instead of thinking about numbers, we can start thinking about intervals here. That's the first important observation. Okay. So what makes the score large? That's score for us is L square, right? Suppose length is equal to 2, then score is 4. Length is 5, then score is 25. So now you can ask this, okay, does the problem require many small segments or a few large ones, right? So many small segments like 1 1 2 2 3 3, or 1 1 2 2 3 3, one large one, which is more rewarding? This is 2 square, 2 square, 2 square, 3 into 2 square, then 4 into 3, 12, but it is 6 square, which is 36. So you can see the large segments are more rewarding, right? So also you can remember one thing, there is a mathematical identity a square plus b square plus 2ab is a plus b whole square, right? Since 2ab is greater than 0, right, then we get always a plus b whole square is always greater than a square plus b square, right? So this tells us the problem loves large intervals, right? Okay, so whatever is large here, a or b, if we increase the interval size and then square it, then this problem is like large is more greater always, like if we have smaller, right? 2 smaller is less than 1 big, right? Always. This is clue number 2. So can an interval be partially deleted, right? One interval can be partially deleted, like suppose we have this array 1 2 3 and 1. This is an interval, right? Interval of 1 is this. Now imagine I delete 2, right, first, then later 1 2 1, right, 1 3 1, like this. Shorter interval means small square, which is worse. So I ask, okay, is there a reason to shorten an interval? So there is no reason, right? So this is exactly the editorial lemma for us. So now I discover something huge here, right? Instead of thinking millions of changing arrays, right? Millions of changing arrays, I can think original intervals. Original intervals. The array is almost an illusion. Okay, array changing is almost an illusion here. This is the biggest insight of the problem here. Okay, so once intervals are fixed, right, what remains? Suppose we have this 1 2 1 2 here, right? So here intervals are 1 to 1 and 1 is 2 to 2, right, like this. So interval is never changing, okay, only their order of deletion changes, right? So I ask, can I perform from left to right? Usually if the intervals are fixed, prefix db becomes possible, right? So intervals are fixed here, only order of change deletion is changing, okay? So now think about the last position. Think about last position, okay? Think about last position here. This is many like everyone's favorite DP trick. Forget the whole array, okay? Look at only the last element. Suppose we are computing the answer for array of 1 to I. That's it. Ask what can happen to position I. Okay, nothing else matters. So this position I only has two possibilities. Okay, either it is standalone or it belongs to interval of its matching value, right? So there is literally no third possibility because every number appears exactly twice here. So whenever the number of possibilities for the last element is tiny, often 2 or 3, a DP occurrence is usually close. Okay. So we can write the occurrence like this. If the last element is alone, so then we can do DP of I is DP of whatever we have the answer from I minus 1 elements plus 1 only, because 1 square is always 1, right? If the element is standalone. If it joins its partner, suppose partner is at L, then what it will become? DP of I is DP of L minus 1 plus R minus L plus 1 square, length square, right? Then this is exactly the recurrence for us. So, and why didn't we think about graphs, greedy and binary search? Because the problem gives clues to us, right? Clue 1 is like, okay, delete the continuous segment. So this is like intervals for us, okay? Clue 2 is process until array is empty. So think it's DP here, right? Clue 3 is every number occurs exactly twice, right? So every value defines exactly one interval. It's a huge simplification here, right? Clue 4 is score is length square. So large intervals are rewarded, right? Oh, also operation only affect one interval at a time. So maybe the last interval idea works here, right? So this is not graph, this is not tree, these are intervals are there. Intervals can overlap also, right? So guys, let me try to code this for you right now. Okay. So let's go. Let's include bits standard ++.h, right? Okay. Now what happened? Okay, then we have int main, our main loop, right? One more thing for competitive programming, like sync iOS sync with stdio, it will be false for us. Okay, and other thing is cin.tie, it's a null pointer for us. Okay, it's just optimization for competitive program. Okay, then we have one input integer t for test cases, right? In t here, while t minus, what we can do, we have integer n, number of elements, right? C n is n always. Then we will have one array, right? Vector integer, right? A 2 into n comma, okay, plus 1 also we can have for is equal to, if I am coming from index 1, right, is equal to 2 into n I plus and c n is a of I, right? So we have our input completely, and so we will have a vector called first, which will store position of value x, first occurrence position of value x. Okay, so let me show you, like vector of n first, okay, n plus 1 comma minus 1. It will store the whenever the first occurrence of value x, then it will store the index. Okay, then we will have this dp, which will score best score prefix from 1 to I, right? So vector of we can take it as long also, dp of 2 into n plus 1 comma 0, right? Now we will have that loop for int of I is equal to 1, I less than equal to 2 into n, right? I plus plus, like this. Now what we can do, guys, first one option for us is like, okay, AI is singleton for us, right? So what it can do, like dp of I is equal to dp of I minus 1 plus 1, right? If it is like there is no pair for this element, right? This is one thing. And now with int of x is a of I, this is the element, right? Next option for us is we will use the full block from first x to I, right? So if first of x is equal to minus 1, right? And what we will do, first of x equal to I, we are storing like when this x has occurred, right? So first of x is I here. If it is not the case, right? If we are encountering it second time, else integer of L is equal to first of x, right? And long length will be like I minus L plus 1, right? And long left score will be like equal to L is greater than 1, then dp of L minus 1, else it is 0, right? This will be the left score for us. Then we have dp of I is equal to max of dp of I comma left score plus length into length, right? Well, it means length square here. Whatever the maximum, it will be here, right? Then after that we will have this output C out dp of 2 into n, right? So then, and at the end we can turn 0. Let me try to submit this now, guys, for you. I can choose a file which is my.cpp and try to submit this. If something I broken down in Codeforces, do not panic. You can try to Control R. What? Wow. What a So you understand this, guys, right? Whatever happens, I think we have solved this. Okay. Don't worry. So whenever it comes back, we will. So understand this, how we approach this solution, right? So we one thing actually very interesting in the solution, as you can see here. So we can how we track the first occurrence of that L and R for each element, right? And if it is single and we are coming from left to right, solving this from left to right, right? Like that. It's very important also. So whatever the maximum solution it is, if we can get from here to plus 1, right? So very interesting solution, right? We can put this solution in hard problems, right? Very interesting it was. Alright, thank you so much, guys, for watching, and we will meet you tomorrow. Alright, we'll meet you tomorrow. And the next